this is quite important from your exam point of view. All right, let's get it started. The lateral or the curved surface area of a closed cylindrical petrol storage tank. Fine, okay, works so fine. They give us the diameter 4.2, and then the height has been given to us 4.5 meter. All right, so this is the petrol tank. Okay, so the first part they want us to find the curved surface area or the lateral surface area, which means this region here. Of course, the other side where we can't see, right? Same thing here, this region and also the region at the back. All right, so we already know the formula, twice pi r h. So before that, diameter has been given. Let's find the radius, d by 2, right? 2 ones are 2 2s are 2 ones are, and then our radius is 2.1 meter. Height has been given 4.5. Now we just have to put it directly in the formula, twice pi r h. Pi is 22 by 7, r is 2.1, height is 4.5, right? So once we have put the value, 7 into 7 into 0.3, right? Now you multiply all this, 2 into 22 into 0.3 into 4.5. The lateral surface area, we're going to get it to be 59.4 meter square. Let us also find the total surface area of this tank. Okay, total surface means what? The curved region plus this upper and the lower, right? We already know the formula, total surface area of the storage, total surface area of a cylinder, twice pi r plus h. R is 2.1, h is 4.5, right? And then pi is 22 by 7. Then once again, 7 into 7, 7 into 0.3. If you add these two, you'll get 6.6. You multiply 2 into 22 into 0.3 into 6.6. We're going to get a total surface area to be 87.12 meter square. Now let's go back to the question. This 2, how much steel was actually used? Okay, how much steel was actually used? Because see, this is the finished product, right? And like I told you, we always have to take extra, right? So that if you make mistake, we can compensate it. Clear? So when you look here, this total surface area is only after the wastages and all. We do not know how much we actually used. All right, that is why they've given us that if 1 by 12 of the steel was wasted, which means we got here a total surface area to be 87.12, right? Which means that in other words, it should be more than this, maybe 90, maybe 91, because this is only after the wastage. All right, so let us now find the actual amount of steel used. Like I said, since we don't know, we'll take it to be y. All right, and steel wasted was how much? 1 by 12 of the total amount, right? So y, 1 by 12 of the total. When you multiply, you will get y by 12. Therefore, when you do this, amount of steel, the total amount of steel required minus amount of steel wasted, do I get a total surface area? I get, right? This is after the wastage. All right, that's why you can see here. Then the amount of steel required is y, right? And the wastage is how much? Y by 12. And we got a total surface area of the tank to be 87.12. Now remember that below this y there is 1, right? So it will be something like this: y by 1 minus y by 12. And if I find the LCM, it will be 12. What is my first numerator? Y, right? Then into 1 into how many times are 12? 1, 12. Then minus, what is my next numerator? Minus y. And then 12, how many times are 12? 1 time, right? Then y into 12, I'll get 12y. Y into 1, I'll get y. Then 12y minus y will be 11y. Now remember, I'm trying to find this y, so this 11 and 12 I have to do cross multiplication. 12 is in the denominator, it will go up in the numerator. 11 is in the numerator, it will come down. Clear? So now when you divide these two, you're going to get 1.09, and once you multiply these two, you're going to get y equals 95.04. So this was the original. Okay, therefore 95.04 meter was actually used in making the tank. And remember, this is only after the wastages and all which came. All right, after the wastages, total surface area.